although I'm very passionate about neutrinos and neutron stars, I'm curious about life, right? Science as well. So I think that it's nice to help students. For me, it's a passion really to help students to find what they like to do, because I think ultimately I'm happy where I am because I follow that passion. And so I want to help them, I want to help them with finding that passion and going for it, giving them skills so they can go for it. I'm Liliana Caballero, Department of Physics at the University of Guanajuato. I was born in Bogota, Colombia, and that means I grew up being surrounded by mountains and salsa music and coffee. I've been in many places before coming to Guelph. One of them was being in the States, in the United States, in Indiana. I did my PhD there. And then I stayed in the States. I went to North Carolina to do a postdoc, and then I moved to Washington, to Seattle, and I continued with a short position there also as a postdoc. Then I moved to Germany, and I was there doing another postdoc, and then I ended up coming here in Guelph after going through Michigan to do also a small position over there. So yeah, all over the place. What I do is to study nuclear astrophysics. So I do theory, and that means that all my work, when people ask me about where is your lab, my lab is a computer. I love my job because it's just right at the intersection of a couple of fields, that is nuclear physics and gravity. I study how highly dense matter behaves, and by highly dense matter I mean think about the mass of the sun, all cramped so dense that the radius is from going from the downtown Guelph to the Highway 401. So that's quite dense, and that's one of the densest objects in the universe. So the only thing that is as dense as this kind of objects is a neutron star. And the neutron star and the nucleus are very similar. So whatever we do, or my colleagues do in a lab, will inform me of how a neutron star behaves. And similarly, whatever I get from observations and interpret with my computer simulations, that will inform the nuclear physicists about how the nucleus behave. That's why I like my field of work so much, because then I'm not an only person working in a field with only other theories trying to get who gets the better model. No, I have to go and compare with people that really get data where things are happening in real life. Like if you do an experiment, right, in a nuclear physics lab, like many of our colleagues here go to Triumph to do experiments. So then they get all this data that is how nature really behaves. And then I get to compare with my predictions. And then we'll see, okay, I think I have to tweak my model a little bit more. And why do I need to change it? What is the fundamental part that I need to change? So that is one part. And the other part is about observational data, because now there is a variety of different signals that we can get from one single event. For example, we have gravitational waves, we have X-ray observations, we have neutrino observatories. So all these kind of different electromagnetic and particle emissions happening when two neutron stars merge. So I find it fascinating how we can put really all the pieces of a puzzle together and make sense of it. And that informed really from the big macro, informs the little micro models that we're trying to handle. Working in my group, I really care about mentoring my students. I really care about the students that I'm supervising. They learn a lot about nuclear physics because that's the main topic that I'm working, but they also learn from other areas like astrophysics or gravity, and they also learn about computational physics as well. So it's a little bit of different skills inside the field. I really want them to succeed in whatever they decide to do, right? So the advantage of my field is that it really gives people skills that are applicable outside the academic world, right? Because someone may want to have a startup, okay, then you learn critical thinking and problem solving skills, and that works fine. We have students that have gone to finances, for example, and they had very nice careers. I think because I was at some point in a situation in my life that I didn't know what I'm gonna do. I have all these skills I'm so passionate about what I do as a physicist. It really blows my mind to study this kind of objects. I'm so curious about them. But at the same time, we live in this world, and the job market is out there. So we need to have skills that allow us to attack different problems in different ways. There are many people that are underrepresented, and this is not only for women, but there's many other groups that they cannot shine the way they could be because there is still some systematic barriers. So I think that I think Guelph is a good place to move forward, because I think our department is friendly in that regard, and we are really creating a network of people that we can share stories, share how we overcame some challenges. So I think I love that from Guelph. Guelph is awesome because Guelph, the University of Guelph, and particularly the department, is very good for my research because I get top colleagues, right? Colleagues that are leading the world of nuclear physics and gravity, and then I get to talk to them, right? It's nice to have these ideas back and forth. Also, well, at the beginning when I just arrived to I was the only one doing nuclear astrophysics, so I was happy to be able to attract students that were interested in this field. And the more people that come to this field, the stronger we get all together. So it's awesome. It's fantastic to have conversations with my colleagues. So Guelph is a very nice place for me, research-wise speaking. As city life, I love it too. Not too small, not too big, that I'm stuck in traffic, right? I love nature around Guelph. I think that I just like the city a lot as well. And also, I think one thing that I realized is that when I was young, and I didn't know how to be a researcher, I always felt, am I able to do this? I'm like, am I good enough, right? So that was, we call the imposter syndrome. So I think what helped me at the time is to embrace my ignorance, right? Okay, I don't know about this stuff, but there is nothing that we have done as a human race that I cannot understand. Like, our brain has overly developed to understand other people's work. So I think that being stubborn in that regard and embracing my own ignorance kind of helped me. So I want to kind of invite others to say, okay, I don't know this, but I'm okay with myself about that. And I'm gonna just do this because it's fun, not because I have to prove myself. And that I think that kind of gives you a different energy and you enjoy the journey. No matter what, you have some goal, but you enjoy the journey to get there.